Okay, business algebra. In the last video, we talked about some of our rules for the end behavior of polynomials based on graphs. Now let's see how we can figure it out based on the equations. So determine what the graphs look like on the outsides given the following equations. That's a nice way of saying determine the end behavior. And your end behavior is determined by your largest power of x and the coefficient. So let's look at 1. It's negative 0.07 x to the fourth. So for here, a is negative because there's a negative side, and our degree, n, is even. Now, if it's negative and even, this means it behaves like negative x squared. And to behave like negative x squared, we know that takes the parabola and flips it downward, which means as x goes to infinity, f of x goes to negative infinity, because it's like a downward facing parabola. As x goes to negative infinity, f of x goes to negative infinity. Now this is backwards. I always did negative infinity first, and the notes, it doesn't matter the order you put them in, as long as you get them both right. Okay, furthermore, let's do number 2. F of x equals x to the fourth plus 2x cubed plus 3. Again, we only care about the leading term, which is x to the fourth. Here the a is 1, so a is greater than 0, and n is still even. And of course, even powers means the f of x is the same thing, but this one means it'll be like regular x squared. So as x goes to negative infinity, f of x goes to positive infinity, and as x goes to positive infinity, so this is the left side, and the right side, f of x goes to positive infinity as well. Because of course the x to the fourth is much more powerful as you plug in larger and larger numbers. Now the leading term for number 3 is negative x cubed, so a is negative, and n is odd, which means this is like negative x cubed, which is what we were looking at there. So as x goes to negative infinity, f of x goes to positive infinity, and as x goes to positive infinity, f of x goes to negative infinity. Okay, so let's put it all together. We talked briefly in the last video about what's happening on the outsides, and we talked about what's happening at the zeros. So we have two options when we're actually plotting polynomials to use those rules to our advantage. The second option is to use what I call a chart. We sometimes used graphing a chart for the things like inequalities in quadratics, which you may not have seen before, but we'll talk about how the chart goes. So we'll do this in two different ways. We'll do one problem using what we know about the behavior, and we'll do a problem at least using the chart. So find the zeros and plot all of the x-intercepts. Plot the y-intercept by plugging in 0, and then use the end behavior in multiplicities, or make a positive-negative chart using the zeros as breaking points. So let's talk about what this looks like. So if it's already factored for you, like in number 1, you will just simply set each factor equal to 0. So 2x plus 1 equals 0, x minus 2 equals 0, x plus 3 equals 0. So here we get x is negative 1/2, x is 2, x is negative 3. So these are all zeros, so that means their y value is all 0. So negative 1/2, 0, 2, 0, negative 3, 0. You take those and you plot them. So we have negative 3, 0, on the furthest left, negative 1/2, 0, 2, 0. Now plot the y-intercept by plugging in 0. So f of 0 equals, all the x's will become zeros in here, so all that's left is the numbers, 1 times negative 2 times 3, which is negative 6. This gives us the point 0, negative 6, just down here. That means we know from both of these zeros we have to be going down, because the only way to get down to the -6 would be going down. And if we were to cross and go up somewhere, there would be another 0 in the middle to help us get down there. Now, to look at the leading term, if it's factored, you just multiply each of the first terms together. So that's 2x times x, which is 2x cubed. So that means our end behavior will seem like 2x cubed, which is an a is greater than 0, and degree n is odd, which means it should be going up on the right and down on the left. So we can roughly sketch this. That means coming out of my right 0, I need to be going up. On the left 0, I need to be going down. You can plug in numbers to make sure, but this should be the case all the time. So this should be going up, since it's just a sketch. This one should be going down. So what we can do from here is talk about what's happening at our zeros. Are any of these raised to any powers? They're all multiplicity 1, which means every time it will cross normally. Now that may mean different things to different people, what it means to cross normally, but if we're roughly sketching, all that really means is that if it's going to go from below the axis, it has to cross to above. Then it's got to turn around so that it can cross again at the next 0. We know it goes down to the 0, -6. And then it's got to cross again to go up. Now, is this perfectly accurate? No, but is it a good representation of what's happening? Yes. So that's using our rules from the last page. So the question is, how can we use that chart that I talked about? The chart requires you to do the same things at first. Set your values equal to 0. So x squared equals 0, which means x equals 0. 3x minus 5 equals 0, and x plus 4 equals 0. This is x equals 5/3. X is -4. So we have 0, 0, 5/3, 0, -4, 0. Now, there's no reason to plug in 0 because we already have the 0, 0 there, but we do plot this. 0, 0, 5/3, 0, -4, 0. What this thing does is it takes our zeros, -4, 0, and 5/3, and it makes a positive negative chart, so we plug in a value in each range. So -5, say -2, 1, and 2, and it plugs them in. And it just keeps in mind if they're positive or negative. Now remember, anything squared is positive, so let's talk about f of -5. Just in the terms of what I have here. -5 squared is positive, so what about here? 3 times -5 minus 5 is negative, so positive times negative. -5 plus 4 is negative. What's a positive times a negative times a negative? It's positive, because the two negatives can't become a positive. So this is positive. Now we plug in our next value, -2. -2 squared is, of course, always positive. 3 times -2 is -6 minus 5 is negative. But -2 plus 4 is actually positive. Positive times negative times positive is negative. Do the same thing for for 1. Positive. 3 times 1 minus 5 is actually still negative. 1 plus 4 is still positive, so positive times positive is the same as the last one. It's negative. And f of 2 is positive. 6 minus 5 is positive. It's positive, which is positive. Now, how does this help us? This tells us on what side of the function I should be. I should be on the positive side on the left of -4. On the negative side, between -4 and 0. Then on the negative side, again, between 0 and 5/3, so it might level off and go back down. And then on the positive side, again on the right of 2. And we'll talk more about this in the next video when we do the next problem, but that is another strategy for graphing these.